Hi, a viewer called Dave asked would I be to have a look at these two battery chargers. I think he said this one's completely dead and this one's got a bit of an unusual fault. So let's have a look at this one first. I'll just get this one out of the way. And what he said was the battery light shows that it's empty, but then it keeps switching itself on and off. However, if you set it to lithium, it actually seems to charge. So let's just switch it on. So it looks like it's just gone through its reset process there. And it's shown 12 volts. And now it just seems to be swapping between standby and 12 volts. If we press the mode button and change it to lithium, which is the blue one here, it looks like it's actually starting to charge. So it's a bit of an unusual fault, this one. So I'm not sure whether we'll be able to repair it or not, but we'll have a go. So I'll just switch it off, disconnect it from this battery here. And let's see how it comes apart. Now I have had a look at a charger similar before. It was a smaller one, I think it was the 2 amp one. And that had a diode gone on it, if I remember rightly. So looks like you've got to take these 4 bungs out. And I think these are those triangle shaped screws. Let's just zoom down and have a look. Yes, they're like a triangle shape there. So I'll just go and see if I can find a screwdriver to fit those. Back with a suitable screwdriver. Right, let's see how it comes apart. It looks like the PCB might be glued in. So I think the first problem I'm going to have is actually trying to get this apart. There's just no plate on the wires. I've got the wires here. I think that was a temperature sensor, if I remember correctly. I'm going to persevere with this and we'll see how we'll get on getting into it, but I think I might actually break this trying to get into it. You can see all of the resin stuff poured there. Well, after a bit of persuasion, I managed to remove the bottom of it. But now I've got all of this stuff here to try and pick away by the look of things. So I'm going to have to try and sort that out next. Well, I've been working on it for about half an hour now. I've got this plate off that had this silicone stuff all over it. And now I'm getting pretty much down to the circuit board. I've just desoldered the mains cable here, which gives us a little bit more access into it. But it looks like the whole thing is covered in all of this resin stuff, so I'm not sure how repairable this is going to be. I mean, this is just a nightmare. This thing's definitely not made to be repaired. But I'll persevere and we'll see how we'll get on. But I'm not too hopeful on this one. It's just even trying to get into any of the components to even measure them. I mean, look at that. It's like just filled with thick silicone. Right. I'll see how I get on with this. Well, much later, I've actually managed to clean all of this silicone off the board. So I think we'll get it under the microscope and we'll have a look to see if we can see anything obvious. So this is where the power comes in over here. Looks like we've got a bridge rectifier here. And it looks like it charges up a bank of capacitors over here. We've got a little switch mode power supply. Let's find something to point with there. Looks like we've got a little switch mode power supply here, which I think is the main battery charger. We've got 3 optocouplers there. And we've got a separate power supply over here. And I think this one does the logic for the actual brains of the unit, which is, if I can flip it over there, and this little circuit board here. So this is the control panel circuit board. So that's the actual brains of the unit. So this is the power supply that controls that. And then the main battery charger seems to be this part round here. We've got some rectifier diodes here. Looks like a current sense resistor. We've got an inductor here that goes from there to there, and then this is the output, so just here and here. I mean, some of the numbers came off the resistors when I've been cleaning it, but what can you do? Not sure what that IC is there. Probably an op amp or something for measuring current, maybe. Could well be. So I think the next thing we're going to do is plug it back in and we'll try and measure some voltages. We'll see what voltages we're getting where, I think. So I've got it hooked up to a battery. I'm just going to switch it on. I'll just go on to volts DC. We have got some markings on this board here. I'll see if I can just zoom down a little bit on those. Just being very careful because this is live, obviously. So we've got signal ground, and then we have over current on off. So that seems to be getting triggered. I don't know. Overcurrent PWM. Let's see what that measures. I seem to have a constant 0.7 volts on that one. So I'm not sure why it's doing that, but it seems to be thinking it's drawn too much current, I think. That's what it seems like so far anyway. So I just thought I'd try and measure how much current's actually being sent into the battery. And the answer is not a lot, next to nothing. So it doesn't appear that we're actually getting any current out of this. Briefly went to 0.1 there, but... So what I thought I'd try is I put a 470k resistor between the output and the battery. And I'm just going to measure on the capacitor here, on the output of the power supply. I've just got the resistor there so the battery charge actually can see there's a battery connected. So we should get about 14 volts or so on this capacitor here, but we've actually got nothing. So it looks like the main power supply here isn't operating. So I think that's the problem area. And I think the current sense thing's just kind of a red herring because it's not actually having any current because the power supply isn't running. So it's just kind of tripping backwards and forwards, I think. I'm going into standby and then starting up again, and then I think that's what it's doing. But we're not getting any voltage there at all. I'm just going to switch this off a second. I'll just wait for the capacitor to discharge a sec. And I think we'll just check the output diodes first. Just voltage in it. We don't have any shorts. I know we've got two MOSFETs here, but they're for switching the voltage to the actual output. but we don't seem to be getting any voltage here. I was getting a reading on those a moment ago, but I don't seem to be now. What? This is some... I haven't got the battery connected. I was just wondering whether there was some charge in the capacitor or something there. That's better. Yeah, so those diodes seem okay. So we've got 3 opto-isolators here. I might get this back under the microscope and we'll have a look around this area and we'll start checking some components. Let's just check that. Yeah, that's okay. Right, I'm going to get it back under the microscope. Right, let's just see what we get on some components. That looks okay. Just checking to see if we've got any shorts and any capacitors there. It's quite a low reading. That could be that we've got a 22 ohm resistor across it and a 33 ohm. So that's what that might be, but that could be suspect. I think it's just voltage in the capacitors there. It's giving us false readings. I think the only thing I've found up to now is that diode looks a little bit suspect, possibly. I seem to have the same reading both ways on that one. Which looks a bit odd. I wonder if I can see what that IC is. Let's see if I can zoom in a bit on it. So that looks like 63L456. Right. Let's see if I can find any information on that. So the 2 diodes that I'm getting weird readings on is this one here, which is marked 6X1, so possibly a 6.1 Zener. And the other one is this one here, which is marked T4Y. But I think it might be because I'm measuring across these resistors here. So I think I might take those off and just measure them out of circuit, just to make sure that they are okay. Yeah, that measures okay. Right, that's the diode refitted. Let's have a look at this one then. Let's take this one out and check this one. Right, let's see what this measures then. That measures okay as well. So not that. So I've had a look online and I think it's an OB2263 and that's the pinout of it. And that seems to match with what the pinout is on the IC here. So I might power it back up and we'll see if we get power between ground and that pin there, to see if the chip's actually getting any power. So I'm just going to switch it on, go into volts DC. Right, so it's on now. I think that capacitor there is across the power. And I've only got 0.1 of a volt across that capacitor there. I'm just going to connect it to the battery. So it should actually be charging. So that's it connected to the battery now. I'll just try and get on that capacitor again. I've only got 0.7 of a volt there. Oh, I went up to 1 volt there. And I would have thought that IC probably needs more than 1 volt to work. So something definitely doesn't look right there. So I just thought I'd check the voltages on the opto-isolators here, just to see if any of those are stopping the power supply from running. I've put the diodes back on and everything seems okay. So let's just see what we get on these. I'm getting about 2 volts on that one. And it's just dropped to 1.1, and that's odd. I'll just zoom out a second. It was actually just charging there. There, it's actually charging now. Yeah, the next charge lights just came on. So I wonder if there's something wrong with this opto-isolator here. Let's just see what we get on this output cap now. Yeah, we've got voltage in. Yeah, it's got 3 lights on there now. So I wonder if there's a problem with that opto-isolator. So I might resolder all of those joints around there. Yeah, look, it's nearly fully charged now. Right, I'm just going to switch this back off. I'm going to get it under the microscope again. We'll just try touching up some of the joints around here, because I think it might be just a bad connection or something around there now. Right, got it under the microscope again. So I'm going to put some flux on some of these components. A bit blobby that one, like. I'm just going to wick some of that back off, I think. Right, I'm going to give that a clean up and then we'll see if that's made any difference. Right, just finished soldering that up. Let's see what it does now when we switch it on. Well, it looks like it's charging. Yep. So I wonder if it was just a bad connection on a resistor or something around about that opto-isolator. I think this one seems to be working now. Excellent. Right, I think we'll put this one back together. We'll give it a final test and then we'll have a look at the next one. Well, some bad news it seems. I started putting it back together. I turned it over just to sort of and give it a quick test just to make sure everything was working, and nothing lit up. So I thought, right, I'll take it apart again. So I've took the display board back out, and if I just measure the voltage going to it, we have 5 volts there. But it just seems completely dead. It's just not doing anything. And the weird thing is, if I measure the reset pin, we've got no voltage on there. We should have like 5 volts on there. So I've tried pulling that up with a little resistor. That didn't seem to do anything. The MCU wasn't getting hot or anything. It just seems to have just given up the ghost. And I've got no idea why. See, nothing got shorted out or anything. That's it. I just screwed it into the case there. I put the little insulator back in. I tried it and dead. So I thought if I pulled one of the wires, so I've checked the continuity between here and there, all that's okay. So I'm not sure what's happened with this. The MCU, I've tried to find the pin out of it, but unfortunately that number that's on the MCU seems to be a custom part. It is a HT50F80 and nothing shows up for that number apart from one post on EEV blog where somebody else was looking for a similar chip. So they think it's a custom part. So looks like a no fix on this one, so let's hope we do better with the other charger. Right, let's see if we have better luck with this one. So he said this one was completely dead, so let's try it on the dim bulb tester. No flash or anything. And nothing at all. Right, let's see how it comes apart. And this one also uses those triangle shaped screws. So hopefully we'll have better luck with this one. Hopefully this one isn't all encased in silicone sealant stuff. All right. Let's just zoom down a bit. So that's where the mains comes in. We've got a bit of filtering, bridge rectifier, smoother cap. So looks like the main transformer. We've got a relay down there. And it looks like a little control board here. So how do we get the board out? Looks like it's clipped down here. And looks like there's another clip down here. Just going to proceed a little bit cautiously because this has been switched on just in case there's any charge in the capacitor. I wonder if somebody's been into this before because it looks like we've got lots of tape around here. Right, just want to check to see if there's any voltage in that mains cap. No. Right, let's start at the plug end then. And we'll just go into continuity. So the plug fuse is okay. It looks like we've got a fuse here. Which appears to be open circuit. check this MOSFET here, just in case that's blown. Just going to diode check. Well, the MOSFET appears to be okay. Let's just check these diodes. Ah. So we've got 2 diodes gone here. By the look of things. Let's see what those are. Looks like 007. So there could be 1N4 007s. And I should have some of those, so it might be worth changing all 4. We also need to see what this fuse is, so I just think I'll start by removing those. Just going to add some fresh solder first. Right, I'll go and see if I can find some replacement diodes. Well, I managed to find 4, so I'll just put them in situ there. I'll just solder those up. Right, that's the 4 diodes in. So let's have a look at this fuse then. And it's a 1.6 amp. Now I'm not sure if I'll have one of those. I'll go and have a look. Well, I managed to find a replacement fuse. So that's the diodes changed, the fuse changed. But I want to check the mains cap. Now I can't check it in the circuit, but I want to take it out just to have a look at it. I'm just wondering what could have caused the diodes to fail. Let's just test it with the ESR 70 gold. .29 microfarads in an ESR of 1.18. Now I'm not sure whether that'll be okay or not, because I know the higher voltage capacitors do have a higher ESR. I'll see if I can find a different one though. Should have one knocking about. Well, I had a look around and I didn't have a capacitor of that value. So I've put the old one back in. Let's just see what happens if we switch it on. Oof, well I didn't like that. I didn't even see where that came from. I'll have to have a look back on the video to see where that came from, but it wasn't good. Well, I've had a look back on the video and I can't see anything, so I'm just going to try it again quick. Yeah, that was the MOSFET went that time. I seen a flash from it that time, so there must be a problem with the control circuit on this. So I guess this is going to need a new IC, new switching IC and a new MOSFET. if it's got a number on that IC or not. I'm going to have to give that a scrape and then see if we can work out the number. So I thought I'd try cleaning the chip with some IPA, isopropyl alcohol, not India Pale Ale. And it looks like it's a 3844B. So UC 3844B. So I've removed the MOSFET, which is definitely gone. You can see a big black mark at the bottom of it, and it measures, I think it's around about 200 ohms between those two pins and open circuit between those two. So that's definitely failed. And what I've done here is I've wired the bench power supply up to ground and VCC of the oscillator chip here. So we'll get the scope and we'll see if we get anything on the gate pin of the MOSFET here, just to see if that's oscillating or if the chip's actually fried. So I'll just set the scope up. I've just got a ground wire going to the power supply here. And switch the power supply on and let's have a look. And we do indeed get a nice waveform there. At around about 39 kilohertz. So it looks like the actual IC is okay. So we might get away with just replacing the MOSFET. Right, I'm going to see if I can find a replacement MOSFET then. So I thought I'd check some of the other components around here. So I thought I'd check the supply cap to the IC just to check that was okay. And it's got an ESR of 5.8 ohms. So that's not right. I have found another cap here that I'm going to replace it with. I didn't have one of the exact value, but it's close enough. You can see that one measures much better. I think this one's 56 ohm and that one's 47, so it should be fine. It's only a smoothing cap. And obviously this one's got a much better ESR than the 6 ohms that one has. Right, I found a suitable replacement for the MOSFET. This one's actually a 10 amp MOSFET and this one's only 8, so it can actually handle more current than the original. And it's got a lower RDS on. I think this one was a 8N60 and this one's a 10N60. So we'll pop this in. It had a little ferrite bead on it, so I've fitted that to it as well. Right, let's solder it up. Just check the heat sink's nice and flat. We'll just cut off these excess legs. So I think the root cause of it has been this capacitor. It's not been allowing the chip to run correctly. It's probably held the gate open too long on the MOSFET, which has then caused it to fail and blowing the diodes and the fuse. So hopefully when we try this, it doesn't go bang and explode everywhere again. I have checked all of the resistors and diodes around here and everything else seems okay. I can't see any other problems on it, so fingers crossed. Right, I've not tried this yet. I've got the dim bulb tester out. So hopefully this works and doesn't go bang, but let's find out. So I'm just going to lean back a little bit here while I switch it on. Oh, we've got a light. Yes! I'm glad this didn't blow up. I think that looks like it. We've got a light on it. Right, I shall put it back together and hopefully this one doesn't fail when I put it back together, and then we'll try charging a battery with it. Right, that's it all back together. I'm just going to plug it in again. Hopefully we get a power light. Yeah, we've got the power light there. I don't know what the mode button does, but it doesn't seem to be doing a lot. Let's grab a battery. Well, that seems to be it. And it's saying it's full. So let's just check the output voltage. You can see it going up there now. So it is actually outputting. And obviously it's saying it's full, so that's why it's switching off. Unfortunately, I don't have a flat battery to test it with. Right, so we'll call this one a fix then. So the problem seems to be in this capacitor here, and that's caused a bit of a cascade failure and blew the fuse as well. So at least we've managed to fix one of them. So unfortunately the other one wasn't repairable. So have you ever had an item just randomly die while you've been repairing it? Let me know in the comments below. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.